Okay, Assalamu alaikum. So we are going to start with the session. The session that I am going to take for you is I am going to take material testing lab for you. Just let me disable annotation. Okay. So the session that I am going to take for you is material testing lab. Yeah. There are two parts in material testing lab. One is part A and another is part B. I would like to inform you what is part A and part B. Okay. What is part A and part B? Part A is lab work of materials and metallurgy. So there are basically two subjects in this single lab, material testing lab. There are two subjects. One subject is material and metallurgy, and the other subject is strength of material. So part A will constitute of the term work and the practical of material and metallurgy, and part B will constitute of the term work and lab work and overall. Matlab, it will also consider that your Viva exam also. So part A and B both will have Viva exam as well as both will have some term work. Okay, so I will be taking your part A. Actually, I will not be taking your part A. Zaki sir will be taking your part A. But since he's not there, I am going to convey in absence of him. Okay, so I'll explain you what is the weightage of this subject. So part A has experiments. There are total 5 experiments and 5 experiments are of 5 marks. Okay, there are no assignments as per the syllabus. There is no assignment weightage given to part A. Secondly, attendance will be divided half. So attendance marks will be 2.5 marks. So overall part A weightage is 7.5 marks as per the term work. Okay. When you go to part B, that is strength of material, it will have 5 to 6 experiments. It will have 5 marks. Then there are 5 assignments. These assignments are totally based on strength of material. These assignments are not at all the part of materials and metallurgy. They are wholly and solely based on assignments based on SOM. Okay. Another thing is attendance. It will also be 2.5 marks. So if you overall estimate it, it will get to 25 marks. So the total term work marks is 25. One thing is there, apart from term work of part A that I'll be taking your assignments, I'll be taking your theory lecture as per the norms. Okay, and I'll be also taking your attendance. So my subject will constitute for 7.5 marks. And another thing that is very important, I would like to highlight for you people. Just give me a second. You can see oral and practical combined is 25 marks. So you might be asked of the practical. There are two sets of practical then. The SOM practical will also be there, MM practical will also be there. You might be asked any one of the practical in your practical exam, and you will be asked oral on both the subjects. So it is a little difficult thing, 25 marks combined. It will have practical exam of either one of the subject, and it will have oral exam for both the subjects. Okay, and combined marks will be 25 for that. I hope everything is getting clear for you. So what is the objective of materials and metallurgy? Earlier it used to be material technology. So materials and metallurgy, when it comes to material lab, material testing lab, right now the subject name is material testing lab. Why have they combined both the subjects? Because both the subjects primarily contribute to the same practical work. Okay? So both the subject contribute to the same practical work. The only difference between metallurgy and material and strength of material is, in strength of material you try to solve the questions, you try to formulate the problems, you try to solve the questions. It is more relevant to analytical part. Okay, and in materials and metallurgy it is more relevant to theoretical part. Even this subject has problems, but since you are not doing metallurgical engineering, you are only doing mechanical engineering. So in mechanical engineering you are supposed to learn all the basics that are in relevance to the theory requirement of the subjects in mechanical fieldwork. Okay, so the first objective, these objectives are not derived by me, these objectives are already given in the syllabus. I'm just stating the objectives. There are two primary objectives of yours. The first objective is you have to be familiarized how to use metallurgical microscope. And why do you want to use metallurgical microscope? Because you want to study the structure of metal. Okay, if you want to use the study the structure of metal, there are various types of microscopes available in the market. One of the basic and the cheapest microscope that is available in the market is metallurgical microscope. Metallurgical microscope is also called as optical metallurgical microscope. So first objective is you need to learn how to use a metallurgical microscope. Second, you need to study the microstructures. After learning the metallurgical microscope, once you know how to optically use metallurgical microscope, what you have to do is there will be various microstructures. Microstructures of steel, I have already stated in the morning lecture. What do you mean by microstructure? Microstructure is viewing the structure when under microscopic view, when you are able to see the view which was not which you were not able to see via the naked eye. The view that you are able to see via the microscope, that view is called as microstructures. Okay, so you need to study the microstructures. Anyone has messaged? What is the message like? Sir, I filled the attendance. Kya hai yaar? Is this required to be asked in the chat box that you have filled the attendance? This was not expected, not an issue. Okay, you can ask me later, you can ask your friends. Okay, the first objective is you need to be familiarized how to use metallurgical microscope, and by using that metallurgical microscope you need to view the microstructures of the metals. Ferrous metals are of two types that are there in your syllabus. One is steel and another is cast iron. What is the difference between steel and cast iron? In steel the carbon content is low, and in cast iron the carbon content is at a higher range. Higher range doesn't mean 10%. You can't have 10% carbon. If you have more than, I think 4.4% carbon, 4.5% carbon, the structure will become very brittle. It will become like graphite, like the nib that you have, or the this your pencil tip that you have, that is very brittle. That is graphite in nature. That is having a lot of carbon. Okay, so if there is a lot of carbon, the structure might get brittle. So what you need to judicially alter the value of carbon content to find steels as well as cast irons. Okay, so what you need to do, you will be given a sample of steel, various types of steel and various types of cast iron. You have to prepare that sample, or you have to view that sample, and you have to study the microstructures of those ferrous metals. Okay, the ferrous metals are of two types. One is steel and another is cast iron. So we will get to the outcome. Objectives are when you complete the course. Okay, and this will be your objective, overall theme of the subject that you need to cover. What will be the outcome? Outcome will be based on what outcome will be based on the topics that are there in your content. Okay, so there are primarily 4 topics that are there in your content, that is there in your experiments or content. 5 experiments, 4 topics, but they have listed only 3 outcomes. I will even give you one more outcome based on the number of experiments that are there. So practically in experiments there are 4 topics. What we will do is we will try to learn the outcome. First outcome, you can see the first outcome. I'll just try to highlight it if it is possible. Yeah. Just give me a second. Give me a second. Yeah. I like to highlight. First outcome is prepare the metallic sample. Okay. So you have to prepare the metallic sample. You should know how to prepare a sample. Okay. Suppose you can see this. This is a USB drive which is used for connecting my mouse. Okay. So you can see this. One second. You can see this thing. Okay, so what you have to do, this surface, if you want to view this surface under microscope, you won't be able to view the microstructures of this surface. You have to specifically prepare the surface. Okay, so how do you prepare the surface so that the microstructure, whatever is the structure that is not visible with naked eye, that should be visible with your microscope. So how to prepare a sample, metallic sample, that is the first primary objective. Okay, that is already written, you can see here. Prepare metallic sample for studying its microstructure following the appropriate procedure. So there is some procedure. We will list down the procedure as soon as we go down the line. Okay. Second, so first what you have to understand is you have to prepare the metallic sample, and you have to view its microstructure, and you have to know what is the procedure for preparing the metallic sample. Okay. So how do you prepare a metallic sample? That is your first outcome. Second is, I have already stated in the morning, heat treatment. Okay. Suppose you are given this sample. Okay. This sample is given to you. What you have to do with this sample, you have to heat it. Suppose you have to heat it at an elevated temperature. What temperature did I inform you? Suppose that temperature is 850 degrees Celsius. Suppose. Okay, so you heat it up in a furnace up to 850 degrees Celsius. What you do next is you keep this metal in the furnace and heat it up to 850. After heating it up to 850, you hold it. Suppose you hold it for 30 minutes or you hold it for 1 hour. based on your requirements. Why do you hold it? You hold it so that the temperature gets uniform from outer surface to the inner surface. To have uniformity of the temperature throughout the surface, what do? You try to hold it for a minimum time, and that minimum time lasts from 30 minutes to 1 hour. Okay, so what you have to do, you have to identify the effects. Matlab, you are keeping this in the furnace, then you are holding it. Okay, after heating you are holding it, then you are removing it. If you are removing it and air cooling it, what do we call it as? We call it as normalizing. I have already informed you. Okay, suppose you normalized and you try to, I have already stated, the way you heat the microstructure and the way you cool it, that also affects your performance, or that also affects your properties, you can say. More proper will be that affects your properties. So the property will get altered when you heat it, hold it and cool it via different means. If you cool it by air, the property will vary. If you cool it by water, the property will vary. Okay, and if the property varies, the performance of this microstructure or this object will also vary. Okay, or this, you can say, this metal will also vary. Okay, so what you have to do, you have to identify the effects of heat treatment on microstructure of medium carbon steel. Okay, what you have to do, you have to study the effects of heat treatment on medium carbon steel. I would like to inform you what is low carbon steel, LCS, what is medium carbon steel, and what is high carbon steel. If the carbon percentage is from 0.1 to 0.25% carbon, okay, carbon, so we call it as low carbon steel. If it is ranging from 0.25 to 0.6 weight% carbon, we call it what? We call it as medium carbon steel. And if it varies from, suppose, zero point 0.6 to 1.5 weight% carbon, okay, we call it as high carbon steel. Actually, the carbon content in the steel can go up to 2.1%, but we never, it can go up to 2.1%, but we never consider steel to be a part of, we never consider the system which is having more than 1.58% steel to be a part of any of the system. Okay, so you can, in steel you can have up to 2.1%, but if it is limited up to 1.5%, then those kind of steel is called high carbon steel. What is mild steel? Mild steel is not at all medium carbon steel. There is a slight difference between mild steel and medium carbon steel. I would like to inform you, mild steel has exact 0.2 weight% carbon. Okay, weight percentage of carbon is 0.258% carbon, and it has 0.05, sorry, it has, one second, 0.055%. Morning I told you, phosphorus and sulfur. Okay, so there is a difference. There is a difference between mild, medium carbon steel and mild carbon steel. Both are different. What is the difference? There is a difference of phosphor and sulfur. Phosphorus and sulfur. Phosphorus and sulfur is not added to mild carbon steel, but it, sorry, it is not added to medium carbon steel, but it is added to mild carbon steel. So what you are being asked is, you have to study the effect of heat treatment. Matlab, what will happen if you heat it by normalizing? If you adopt the standard procedure of normalizing, what will happen? What will happen if you temper it? What will happen if you harden it? What will happen if you normalize it? Okay, now since you have heated the sample, suppose you have heated the sample, after heating the sample you again have to prepare its surface if you want to view the microstructure, because your objective is to view the microstructure of medium carbon steel. Okay, so if you want to view the microstructure of medium carbon steel, you again have to go to the first experiment. First of all, what was the first experiment? After heating, it is not like you can directly keep it under the microscope to view its structure. What you have to do, you have to prepare the metallic sample. So what you are going to study in the first experiment, that will be repeated again in the second experiment. Okay, so basically whatever things that you will learn in the first experiment, you have to repeat it in the second experiment. So this is, I will like to clear this thing so that the things get clear from my side. So what is the second objective? Second objective is, you have to identify the effects of heat treatment on microstructure, and you have to, on that microstructure, and that material is medium carbon steel. One more part is added. You had to identify the effect of hardenability of steel using Jomini and quench test. There is a test to determine the hardenability, how hard is the steel, and that test was given by the scientist Jomini. That's why it is called as Jomini and quench test. So you will study the effect of heat treatments as well as you will study the effect of hardenability. There is a difference between heat treatment, matlab normalizing, hardening. What we do in hardening and hardenability are two different things. Okay, hardening and hardenability are two different things. Hardening is a heat treatment process. Get it right. Hardening is what? Hardening is a heat treatment process. Hardenability is not at all the heat treatment process. It is the hardenability is ability of a material to get hardened. Okay, both are different. You will get to know it clearly when you complete the topic. Ability of material to get hardened. Okay, both are different. One is heat treatment process, that is called as hardening. Okay, and another is ability of a material to get hardened. How much hard can it get? Okay, by using which test? By using Jomini and quench test. Okay, you are going to use which test to prove hardenability or to test hardenability or identify the effects of hardenability or how hard the material is? You are going to use Jomini and quench test. One more, so you have already seen that one experiment will be based on this. Two experiments, basically two nahi, I would like to say one experiment will be based on annealing. Okay, first outcome will have only one experiment. Then second outcome will have one experiment on annealing, one experiment on normalizing. Okay, okay, and one experiment on, I think, tempering. Okay, so you will get a lot of experiment here. You can have normalizing, annealing, tempering, hardening. Okay, and one more thing that you can have from this is hardenability by using Jomini and quench test. I hope you're getting what I'm saying. Okay. Okay, so there will be many experiments. We will see which experiments are there in your syllabus from outcome number 2. Okay, last one is to perform fatigue test and draw SN curve. What do you mean by fatigue? I have already told you. Fatigue is cyclic. Suppose there is a shaft. Okay, and this shaft is supposed to rotating at an angular velocity omega. So at which speed or how many cycles, after how many cycles? Okay, after how many cycles? Okay, it fails. I hope you're getting. After how many cycles it fails, if you are able to know that, that is known as fatigue testing. And based on the number of cycle or based on the number of cycle after which it fails, you draw a curve which is called as which curve? It is called as SN curve. Okay. I hope you understood what are the objectives and outcome. I would like to hear from you in the chat box if you're getting what I'm trying to say. Is it understood? Okay, so we can proceed. Okay, thank you so much. So what we can do is we can proceed right now. Okay, so we know the objectives and outcome, we will proceed with it. What is the next thing I will like to? Okay, now the list of experiment comes. I will just list it one by one. First is I will just list everything and I can study, I can teach you directly. Okay, so okay, I would like to use some another color, or is white okay? White, this color will also be good. Okay, we have got so many options. We were not having this much options on board. The only problem that we have is effective content delivery takes a lot of time. So you need to be patient with faculties in regard to this. Okay, so what is the first experiment? I already informed. Just let me shift my screen. Okay, what is the first experiment? I already informed you about the first experiment. It was about metallographic sample preparation. Okay, and etching. I will inform you what do you mean by etching afterwards. Initially, what is your first experiment? Metallographic sample preparation. Why do you prepare the sample? If you want to view the characteristics of metal, okay, and if you want to study the characteristics of metal, okay, what are the characterization techniques? How are you able to find its character? What are the microstructure? For that, what you have to do is you have to prepare the sample, and that sample preparation is called as metallographic sample preparation. Why do you call it as metallographic? Because you prepare the metal sample in presence of metallurgical microscope. That's why you call it as metallographic sample preparation and etching. Etching is what I will inform you later. Okay. Second, I informed you earlier also there can be three experiments. Okay. All are all are kept together in experiment number 2. You can see the experiment number 2. Annealing, you have to perform annealing, you have to perform normalizing, and you have to perform hardening. In which type of steel? In medium carbon steel. And you have to compare the microstructure and its hardness before and after this process. Suppose this is a sample, I have not yet annealed it. Okay, so medium carbon steel will have some microstructure initially. Okay, and that microstructure will have its property, and based on that property I will get some performance. Okay, so this microstructure I will directly view it. This microstructure, single microstructure, will be compared with annealing. Again this microstructure will be compared with normalizing sample. Again this microstructure will be compared with hardening sample. So what you have to do, suppose this is a metal, you will take two this similar metals. First metal, you will directly prepare the sample as per the experiment number 1 procedure. You will prepare the sample, you will view its microstructure, and you will even know what is the hardness. I will get to this word hardness. How do you measure hardness? Hardness and hardenability are again different thing. We will get to it. Okay. So how do you view its microstructure? That is clear by preparing the sample, and you also try to find what is the hardness value of this. What is the hardness value of this sample? The hardness value can be found by using a number which is called as BHN, or it is also called as RHN. When you get into SOM, you will learn about Brinell hardness number. Okay, you will learn about Brinell hardness number. You will also learn about Rockwell hardness number. You can specify the hardness of any material in terms of Brinell or in terms of Rockwell hardness number. This is one of the constant to measure the hardness. Okay, so what you have to do, you have to take this sample, you have to prepare the sample, and you have to view its microstructure, as well as you have to know what is the hardness value in terms of BHN or RHN. What we basically use is Brinell hardness number only. And you can convert Brinell to hardness, so Rockwell, or you can convert Rockwell to hardness also. That is also possible. Okay, and you can even convert this value, hardness value, to a standard unit also, in terms of, suppose you want to find it in terms of stress value. You can even find it in terms of stress value also. That is also possible. But basically what do? We try to find the hardness value in terms of Brinell, BHN, or RHN, Rockwell. Okay. Okay. I would like to clear this thing so that we can proceed properly. Okay. So first is sample preparation. Okay. Second is comparing the microstructure. So what you have to do, first you have to make a sample. Next, what you have to do, you have to make an anneal sample. You have to prepare the surface, microscopic examination, the surface for which microscopic examination is possible, and you have to compare the result of annealing as well as before and after results, matlab main sample and anneal sample. Okay, you have to prepare and you have to compare the results of microstructures as well as hardness. Okay, second, normalize. You know, normalize means air cooling. Similar way, you prepare the sample. Okay, you compare it with this normalized sample as well as with the main sample that was earlier there for two values, microstructure as well as hardness. Similarly, hardened was what? Hardened, we called it as, hardened was water cooled or oil quench. Okay, so hardened is water cooled or oil quench. I hope you're getting. Okay. So what you have to do, again, you have to prepare the sample. You have to see what was the microstructure and the hardness value before and after the preparation of the sample. Okay. I hope you're getting. Next. Third experiment. I told you that this experiment has lot of parts. 4 parts were there. So 5 parts were there on second outcome. So you can see, study the tempering characteristics of hardened medium carbon steel. See, you have already hardened the sample. So what you have to do, you don't have to prepare the surface. In hardened, what do? You prepare the surface. Now, what do you do here? The hardened sample should be tempered. What you have to do, you have to temper that surface. Or what you can do two ways. What another way is hardened sample. You have made the hardened sample. You have prepared its prepared its sample. Okay, metallographic sample preparation. So what you will do, you will try to know what is the microstructure and what is the hardness, okay, of this hardened sample. And what you will do after getting this values, the values that you will get from here, okay, you can use the same sample, hardened sample, and you can temper it now. After tempering, you again do what? You will do again what? You will prepare the surface for microscopic examination, and you will compare the results of tempering as well as hardening. Two results. microstructure as well as hardness value. Okay. So we have already covered 3 experiments. We will get to the 4th experiment. 4th experiment is determination of hardenability of steel. I told you, you have to find what is the ability of a steel to get hardened. Okay. What is the hardenability? Is the ability of a steel to get hardened. How hard can the steel get? That is called as hardenability. Hardening is different and hardenability is different. Hardening is related to heat, related to, what do you say? What was that word? Related to heat treatment. Okay. And hardenability is, again, I am repeating, ability of a material to get hardened. How much hard can it get? Okay. How much hard can it get? So for that, you use a standard setup that is called as Jomini and quench setup. Okay. And that test is called as Jomini and quench test. Okay. What do? You try to measure the hardness value. Okay. You also measure the hardness value, but this is how much hard can you make the material. Okay. Here also you measure the hardness value. Hardening is different. Hardness value is related to hardenability only. But here, what do? You try to make the material as much hard as you can. Okay. And after making that, what do? You try to measure its hardness value by using hardness tester. What are those hardness tester? Again, BHN, Brenner hardness number, RHN, Rockwell hardness number. You can find the hardness value by hardness tester in terms of BHN or RHN. Last one is fatigue test. I have already told you fatigue test to determine the number of cycles of failure of a given material at a given stress. I already told you. Suppose this is my bottle. You can see, suppose this shaft is rotating and this shaft is also loaded at both the point, and the load is tensile load. Load is which load? Tensile load. So if it is rotating as well as it is under tensile load, what will happen after sufficient amount of cycle? This bottle may get failed due to fatigue. Fatigue is what? Repeated cycling load. Okay, that load is called as fatigue load. Okay, so if it gets failed due to repeated cycle, okay, under stress, then this type of test is called as fatigue test. So what do? You try to find after how many rotations does the shaft fails. After how many rotations does the shaft fails, and you try to find that number of cycles. And what do? After finding this number of cycles, what was the last outcome? We try to draw the SN curve. You will know about the SN curve later when we cover this topics. Okay. Then we'll get to the next point. I hope you're getting. It might get boring, but we are going to start. See, study of characterization. I'll just take the point for you. How much time do we have left? I'll just like to see the timing. Okay, 15 minutes. Okay. Okay. So what is our first objective? 1 second. What is our first objective? I have already stated. Can anyone repeat it for me? Anyone? Only 24 students are there. This is not right. Okay, I can't help. Abuzar? Hello, Abuzar. Abuzar? Abuzar? Danish? हेलो इज एवरीवन?
हाँ सर बोलो।
कौन बोल रहा है? अबूजर बोल रहे हैं?
हाँ सर अबूजर बोल रहा हूँ।
हाँ सर, क्या है अपना एम? क्या है? व्हाट इज आवर एम?
स्टडी ऑफ कैरेक्टराइजेशन टेक्निक्स एंड मेटलग्राफिक सैंपल प्रिपरेशन एंड
व्हाट यू आर गोइंग टू डू इन दिस?
मेटल सैंपल प्रिपरेशन होगा।
वेरी नाइस। मेटल सैंपल प्रिपेयर करेंगे बस ना?
हाँ हाँ।
ओके, और कुछ?
यूज ऑफ मेटलर्जिकल माइक्रोस्कोप है।
मेटल सैंपल प्रिपेयर करोगे, you will prepare the metal sample.
Yes,
you will also know how to use metallurgical microscope.
Yes sir.
You will also know how to characterize the material. What are the different characteristics? Like what was the characteristics of mild steel in that bicycle example? You were there in the morning lecture?
Yes sir.
What was the characteristics? Finally,
I don't.
what was the characteristics of metal there?
I don't remember.
Clear light and, do you remember clear light and? You remember? Fardeen? Hello? Hello? Hello, Fardeen? Hello? These people here. Yes, Fardeen. What were the characteristics that you observed in the morning? Oh, what was the characteristics that you observed?
हेलो
Get to your network.
सर आवाज नहीं आ रही नेटवर्क अच्छा नहीं है सर
रहने दो. This is of no use. If you people are not answering, it's of no use for me to teach. It will not give you any kind of assistance from my side then. It is not like one-way traffic. I just have to repeat and you will just listen to me. Can anyone tell me what was the objective of the morning? What were the characteristics that you were able to see? Anyone? Please, anyone? I have unmuted. Can anyone tell me? I have allowed you to unmute yourself. Can anyone tell me? Hello? Let it be. We'll proceed. Actually, I'm going to take this last lecture. I am not going to repeat this. And I'm not your faculty, so I don't bother much about you. If you people are not answering, how can I help? It's of no use for me then. I'll just complete the topic then. It's of no use if I am only repeating and if I am only shouting. What's the purpose of teaching? This is not right. Okay. Not an issue for me. What is our first objective? I'll just inform you. That will be more than enough, I think. What is our first objective? First objective is to prepare the sample. Second is we will know how to use the metallurgical microscope in this experiment. Third, we can characterize. In the morning, we characterized that medium mild carbon steel. Mild carbon steel has clear light, as well as what did we find? It has also ferrite. Okay. And perlite was consisting of two parts. First was cementite and second one was again ferrite. Okay, cementite was called as Fe3C, iron carbide. This was in the morning. This was the characteristics. This was the characteristics. You were able to view this thing. The things that you are going to view in metal will be called the characteristics of that metal. Okay, we'll proceed. Some photos of our lab. How do we prepare the sample? You can see here. I'd just like to select a color for you. You can see this part, this part, this one, this one, this one. You can see this again, this part, all these parts. Okay, these are the cut sample like this. Okay, like we have this cut sample, so we can put this cut sample in this die. Can you see this circle? Can you see this? Okay, so this is the mold that we have to prepare to support the surface. If you want to support this surface, you have to prepare a mold also. Okay, if you want to support this surface under the microscope, you have to prepare this kind of a mold that you can see here right now. Okay, so how do you prepare this mold? This is not related to your this sample microscope. The microscopic examination that you will do will be only of this sample. Okay, this part. But this structure is there to support the microstructure, okay, or to support your main metal. Second, I'll just show you. First is cut sample, metal sample in a mold. This is called as mold. Okay, this part, this black part or this white part that you can see, this is called as mold with resin. Okay, we use some kind of a resin, and with resin we use some hardener. Okay, so that we can prepare this kind of mold. How do we prepare? We will get to know once we complete this experiment. One second. Yeah, one second. You can see this is the mold prepared by our student. You can see this. Okay, this was the dye. This was the dye, or you can say this was your mold. Okay, this was your mold. Okay, this inner part, you can see this white part. This white part is nothing but similar to this, or similar to this black. This is resin with a hardener. Okay, you can prepare this. This was prepared last year by last year batch in our lab only. And where do we find this metal? Since you are not able to find this metal, I would like to inform you this is kept upside down. Okay, this metal part is there below. Okay, so what do? What do you actually do? You take this. You take this part, this mold. You keep the metal down, and what do? You fill this. You fill this mold with resin as well as hardener. You mix resin and hardener in a proportionate proportion, like 25% hardener and 75% resin. Okay, you mix them and you pour this resin and hardness in this cavity or mold, and this metal will be there at the bottom only. Okay, this metal will be there at the bottom, and this mold will be surrounding the metal part. Okay, and you will be able to, by oiling or by some other means or by small application of force, what you can do is you can remove this part from the mold. Okay, if and everyone is getting, let me know. Is everyone getting what I'm saying? First part, is it clear? Okay, okay, thank you. Just let me clear the drawing. So, one second, I am not able to. System is not working. Wait for a second. Yeah. Yeah. We have completed. This is our, you can see here, this is our mold, resin and metal. Okay. Metal is upside down. Resin is inside this. Mold is outside. Okay. So now we can move forward. How do we move forward? Second, this is the resin that we use. Okay. You can see this bottle. This bottle is the resin. And this hardener, you can see this Metatech industry based hardener. This is cold setting compound hardener. It's his name. It's the name of this hardener. It is having some chemical formula. This is also a chemical, but this is a powdered form. Okay. And this is a liquid form. Liquid is how much? Liquid is added in the proportion of 25%. Then powder is added in the proportion of 75%. To prepare what? This resin binder binds with hardener to give the mold. Or you can say, yeah, you can say to give the mold. This part, after you prepare that sample, okay, once you prepare this sample, once you get this sample in a mold, you have to do some processes. What is the first process? You have to take this on abrasive belt grinder. Its name is abrasive belt grinder. It is, once you start the motor, you can see this part. One second, let me just change the color. You can see this part. I hope you are able to see this part. This is our belt. This is our belt drive. When we start the motor, you can see the motor is kept here. When you start the motor, this rotates, the shaft rotates, and on shaft we are placing on the belt we are placing what? Silicon carbide paper, just like the paper that you use for cleaning the surface, that kind of paper, or cleaning the metal part, or filing. Okay, filing your tools in workshop. Similar kind of paper, silicon carbide paper of different grades: 180 grade, 360 grade, 400 grade, 500 grade. These are the silicon carbide grid value. This is called as grid value. What do you mean by grid value? You will learn it in the production process. Okay, these are having different kinds of grade. What do you do? Whatever is your sample upper part, wherever is your sample, since it was kept upside down, you will use that sample and you will grind it. You will push it against this grinding machine. You will, on the grinding machine, abrasive belt grinder, and you will push it against this different grades of silicon carbide paper to smoothen your surface so that you can view the surface clearly. This is one of the first step. Okay, first is preparing the sample. For preparing the sample, first step is making the molding. Second is grinding. So first step you can get it clearly. First step was preparing a molding. Second step was grinding on abrasive belt grinder with different grades of silicon carbide paper. Okay. Okay. So we'll get to the next part. Do we have time? I don't have much time, but still I'll try to complete. This is after making your sample grinded. What you have to do, you have to take it on this double disc polisher. What does this double disc polisher does? It polishes the surface. First was just to grind the surface. It doesn't give the shiny polish. The grinder doesn't give the shiny polish. SiC paper doesn't give the shiny polish. To get shiny polish, what do you do after treating it on abrasive belt grinder with SiC of different grade? You have to take it on this double disc polisher. You can remove this part. Can you see this? You can remove this part. Below this part, there will be some kind of a paper or some kind of a, you can say, cotton cloth. Okay, there will be cotton cloth which will be rotating. This will be a rotating disc. Okay, this disc will be rotating. Matlab when you on the motor or when you switch on the supply, with the help of motor, this part will get rotated. Double disc polisher. First disc and second disc. First you take your sample to the first disc. This disc is actually rotating. You put a material on this that is called as diamond. Okay, diamond, you can say diamond carbide or diamond particles. Okay, you pour diamond particles on this. Okay, with some liquid, you will pour diamond particle plus liquid on this surface, and what you'll do is you will again press it against this surface. Okay, once you press it against this surface, what you'll get is you'll get a more polished surface. Diamond polishes the surface very precisely and very accurately. This is of different grade. Matlab diamond particle will be of different sizes. On first disc, the diamond particle will be of, suppose you can say 6 micrometer. And on second disc, you can say, see this disc, on second disc, it will be of 3 micrometer. You polish it twice by using diamond particle with the help of liquid or resin also. You can use resin. You can pour resin. You can see this. Can you see this? This part, this is used for pouring of liquid or resin or oil on this polisher or disc. And what do you use to polish? You use diamond particle. Okay, diamond particle of different sizes. Initial size for basic polishing, it will be 6 micrometer and or microns you can say, and on the second disc it will be 3 microns or 3 micrometer. Okay, chalo. You can see diamond suspension. Just let me show. Even if it is going above the timing, it's okay because we need to complete it. We won't get the time because I'll not be taking you this topic. So I think if it would be better if we can complete it. Okay, just give me a second. 1 second. Why is it not getting clear? Why is it not getting clear? Just give me a second. Why is it not getting clear? Okay, this was of the last slide. No, this is of this slide only. Why am I not able to clear this drawing? Okay. Okay, what we will do is, you can see this part, you can see this is nothing but diamond suspension polisher. I told you already, this is polisher that you suspended on this disc. Okay, you will suspend this polisher on this disc, and with the help of this fluid, this material will help to polish your metal surface. Okay, we'll get to the next part. Why am I not able to clear this screen? Chalo. So you have already seen many things. Yeah. ये कौन है भाई? एनोट कर रहा है ये? पढ़ाऊं कि नहीं पढ़ाऊं यार? कौन है ये? मैं हूं ना पक्का? Sorry. So this is the metallurgical microscope. Sorry, that was me only. You can see this metallurgical microscope. Can you see? We will we will get into the detail of this metallurgical microscope afterward. I will just like to tell you that these are the lenses. कौन है बेटा ये? Okay, I would like to inform you that these are the lenses. This is the place where we place the workpiece. Wherever, whatever is our workpiece, suppose this is our workpiece which we have prepared with the help of the standard procedure. What we will do is we will put it under this microscope and we will view it through this lenses. Okay, through this lenses we can view it, and this is used to connect this microscope to the computer. We can connect it to the computer, and with the help of proper software we can view the this sample, rather than viewing it through this eyepiece. We can view it directly on the screen. Okay, this is the microscope. That, and one more thing, the microscope has magnification up to 1000x. It is from 50 to 10,000x. Sorry, 50 to 1000x is the magnification of this metallurgical microscope. Okay, second part. Yeah, one more thing, this is the sample. I hope you can see, this was the sample that was prepared. This is the annealed sample that was prepared by our student. Okay, annealed sample that was prepared by our student. You can view this sample. Okay, now what are the steps? I'll just note down the step. First step is sectioning, that is cutting of workpiece. Second is mounting. I have already informed what do you mean by mounting. I'll just try to clear the screen. I am not able to clear it. Yeah, first step, so sorry I'm taking extra time. First step is sectioning. Sectioning is cut a sample from the workpiece. Okay, second is preparation of mold and resin. I have already informed, use some chemical with hardener. Okay, resin with hardener. Third step that you can see here is, you can see the third step. Which is the third step? One second. One second, huh? Just yeah. Third step, you can see the third step. I already told you what do. You grind it, 180 grid, 300 grid, coarse grind. First you will do coarse grind, then you will do which kind of grind? Fine grind. Then what do? You go for polishing. After polishing, there is one more step that is called as etching. I have not informed you about that step. Etching. Why do we do etching? To make this grains, whatever are the grains or whatever are the grain structure, to make that grain visible. Even polishing won't help your purpose, because to make your microstructure visible, you have to pour some kind of a chemical. And when you pour some kind of a chemical, okay, that chemical is called as etchant. What does etchant do? Etchant makes this microstructure visible under the microscope. If you are not pouring etchant, even polishing won't help the purpose. Okay, polishing won't help the purpose. Next thing, after pouring the etchant, what do? You dry it with the help of a dryer. You can even use hair dryer. Then what do? You put it under microscope to view its microstructure. This step is called as observing. So I can just inform you what are the steps. First step is, I like to hear from you. So sorry, I am taking a little time, but it's required. Anyone? What is the first step?
Metal sectioning.
Second step? Second step, beta.
Mounting.
Very nice.
Mounting.
Grinding, coarse grind and fine.
Grinding.
Yeah, coarse grind and
Polishing.
Fine grinding. Then polishing, sir.
polishing.
Etching.
Then drying.
Etching. Then drying and then observing.
What is the purpose of etching?
To make
So to make the microstructure visible,
Very
sir.
nice. Polishing won't help the your cause.
Yes,
To
sir.
make microstructure visible, what you have to do is you have to etch it with some chemical.
Etchant.
Okay. So we will just. Is it okay if I am going for the next slide, because I need to complete it? It will take hardly 10 minutes. Okay. We are just about to complete it. We will just complete it with this slide of ours. Give me a second. Yeah, Allah, why is it not getting cleared? Okay, I have muted. Yeah, what we can do now is we can go and look at this video. Just look at this video. This video will let you know everything. Why have I covered all the basics? Because it was literally required for you to make this video self-explanatory. You need to know what were the basics. Just look.
Metallography, Part 2. Microscopic techniques. Metallic materials are widely used in many areas of everyday life. How are they built up internally? Are there perhaps crystals to be found? And if so, how big are they? What kinds of crystals are there? What is their shape? And are there voids or inclusions? Metallography gives an answer. In this video, we would like to introduce the microscopic technique, metallography. Microscopic means to investigate a workpiece at higher magnification, usually with a light microscope. To have a look at the inside, the material has to be prepared properly, and this is how it is done. First of all, a small specimen has to be cut from the actual workpiece. The specimen is mounted in resin, ground in several stages, polished in several stages, and finally etched. Now the specimen is completely prepared and ready for microscopy. As a typical example, we are going to investigate a bar made from a steel used millions of times, the plain carbon steel C45E, with 0.45% of carbon. To start with, one of our material testers defines the intended sectional plane and marks it on the bar. In this case, it's a longitudinal section. Then he takes the bar to the abrasive saw to cut out a small sample. He fixes the bar securely, prepares the machine, selects the cutting parameters, and starts the first abrasive cut. Intensive water cooling and appropriate cutting parameters are important to keep the material as cool as possible. After finishing all abrasive cuts, the material tester picks up the sample and hands it over to his colleague. For further processing, the specimen has to be mounted in resin. To ensure that the resin will adhere well to the specimen surface, the specimen is placed in an ultrasonic cleaner bath for a few seconds. Alcohol and ultrasonic waves help to remove fat and loose particles from the surface. A short time under the hairdryer and the specimen is clean and dry. To mount the specimen, small plastic molds are suitable. The material tester picks up the clean specimen and carefully places it into one of the molds. The intended plane of examination is at the bottom. Then he pours liquid resin into the mold. A thin...
1 second. I hope you people are getting... Okay? 1 second. I hope you people are getting... Yeah?
Adhere well to the specimen so the specimen is clean and dry.
Okay? 1 second. Now. I'm just stopping because I want you to know the first step is sectioning. The second step is mounting. Okay? Before mounting, they are cleaning. Just look at the steps one by one. 1 second. So sorry. It is moving forward.
To the specimen surface, the specimen is placed in an ultrasonic cleaner bath for a few seconds. Alcohol and ultrasonic waves help to remove fat and loose particles from the surface. A short time under the hairdryer and the specimen is clean and dry. To mount the specimen, small plastic molds are suitable. The material tester picks up the clean specimen and carefully places it into one of the molds. The intended plane of examination is at the bottom. Then he pours liquid resin into the mold. A thin layer of grease at the inner surface of the mold acts as a release agent. This ensures that the cured resin can later be released easily from the mold. Now the mold containing the specimen goes into the light curing unit.
Just 1 second. Instead of using this light curing unit, what do we use in our college is hardener. Because if you put it under the resin, it won't get hardened. So they use light curing system to get it hardened. What do? We use hardener because we have to do it without this light curing machine.
Under the action of intense blue light, the resin polymerizes within half an hour. The resin has cured and embedded the specimen well. As an alternative to light curing resins, many other embedding materials are available. Each of them has its own advantages and disadvantages. Because the top surface is still uneven and slightly sticky, the material tester grinds it there until it is even. He uses a rotating water-lubricated disc equipped with coarse-grained silicon carbide paper.
I hope you are able to understand.
The surface is slightly ground as well to ensure a clean specimen.
Yes, sir.
The preparation of the intended plane of examination. Our material tester begins with comparatively coarse 180 grit abrasive paper. He makes sure to press the specimen calmly and evenly onto the abrasive paper, compensating the tendency for the sample to tilt. He also makes sure not to grind his fingertips accidentally. Now he has achieved an even, relatively rough surface. The specimen is ready for the next step with finer paper.
First was the coarse paper. Coarse paper he used. Now he is going to use the fine paper. Okay, we are going just step by step. The thing is, they are having very high professional instruments. These instruments are not even there in the college. What do? Is we do basic sample preparation, because of which we are not able to view the microstructure that clearly. You can see the precaution that they are taking and the precautions that we take while preparing the sample. We are hardly caring what sample are we going to prepare. You won't even care about it. But when you are into company or industry, they take serious care because they consider that microstructure to be their work. Okay, and that is important for their livelihood also to earn.
New 320 grit abrasive paper onto the disc. Rotating the specimen by 90 degrees leads to new grinding grooves perpendicular to the old ones. In this way, the material tester can easily check whether the old grinding grooves have been removed completely. It is important to use sufficient water flushing during grinding. This keeps the sample cool and prevents the abrasive paper from being loaded with material particles. Grinding continues with 600 grit and 1000 grit abrasive paper until an immaculate, finely ground specimen has been achieved. The specimen is now ready for polishing. An absolute prerequisite for polishing is a thoroughly clean specimen. The ultrasonic bath and running water help to remove any residue from the ground surface. Otherwise, hard particles might be pressed into the polishing cloth and scratch the surface. Hands should be washed as well, so that no unwanted particles find their way to the sample and the polishing cloth. Now the material tester can start with the first polishing operation. He chooses a polishing disc equipped with hard cloth of low resilience, moistens the cloth with a suitable lubricant, and adds 2 splashes of diamond suspension of particle size 6 micrometers.
Diamond suspension.
Under counter-rotating motion, he presses the specimen with high pressure onto the polishing cloth. The diamond particles have settled on the cloth and are now abrading the surface. After about a minute, all grinding grooves have been removed, and the specimen surface already has a shiny appearance. But still there are many fine scratches to be found, resulting from the 6 micrometer diamond abrasive. To remove them, the material tester washes the specimen and his hands again very carefully and polishes the specimen for a second time. Now he uses a softer short nap polishing pad, finer diamond suspension of 3 micrometer particle size and less pressure. After the second polishing operation, the specimen surface has an almost mirror-like appearance. No more scratches can be seen with the naked eye. Nevertheless, the specimen has to be cleaned again and go through a third and final polishing operation. This time, 50 nanometer aluminium oxide abrasive is used. Only then is the surface prepared to a sufficient quality. At the end of the mechanical preparation, special care has to be taken to clean the specimen properly. On the one hand, all abrasive particles have to be removed. On the other hand, the freshly polished surface must not be scratched or damaged. Under running water, the material tester gently wipes the specimen with cotton wool, thoroughly rinses it with alcohol, and dries it with a hairdryer. From now on, the sample is called a metallographic specimen
Dryer.
or microsection. Judged with the naked eye, our metallographic specimen seems to be well prepared. It is now allowed to go under the microscope for the first time.
You can see they have not yet used the etchant. I hope you people are finding it interesting. You might find it interesting only after you have heard about the theory that I told you at length. So he has not yet used the etchant. He has only dried after polishing. Just see the results.
Or rather, onto the microscope. In fact, the design of typical metallographic microscopes is inverted. Inverted
One
means
more thing.
upside down. The microscope objective is not facing downwards as usual, but upwards. This offers the advantage of simply placing the metallographic specimen on top of the microscope stage. The prepared surface faces downwards. Using the built-in digital camera, the polished specimen surface can be observed on the computer monitor. In the polished state, there isn't much to be seen in this material. Only some elongated non-metallic inclusions can be observed. But if these inclusions are of special interest, then the polished state is the perfect one. Inclusions may best be seen here. However, if one wants to see the crystals, the grains and grain boundaries, then the microsection has to be etched.
He's going for
To do
etching.
this, our material tester protects himself with a lab coat, puts on safety glasses, and pours the etchant into a small glass bowl. The etchant consists of a solution of 10% of concentrated nitric acid in alcohol. Now he turns on the water tap, picks up the freshly polished microsection with gripping tongs and immerses it for a few seconds into the etchant. Then he rinses the microsection thoroughly with water and afterwards with alcohol. The hairdryer is again used for drying.
Okay.
The excitement increases. Was the etching time correct? Has everything worked out fine?
Initially, they just saw the inclusions and the foreign particles. Now he wants to see the grain boundaries and grain particles. Just as I explained you in the morning, it is relevant to that only. Rather than that bicycle section, it is one of the part of metal. Okay, it might be anything, but it is carbon steel, plain carbon steel, matlab medium carbon steel, you can say, of 0.45 weight percent carbon. Okay, we are just about to end. You can see.
At low magnification, not much can be seen, which looks characteristic. The tester gradually switches over to higher magnification. In between, he focuses and adjusts the brightness. At medium magnification, light and dark areas become visible. At comparatively high magnification, in some of the dark areas, fine stripes may be recognized. The microstructure in the darker stripe regions is termed pearlite.
This is pearlite. If I could use that thing, that black part is called pearlite, that is having lamella-like structure, okay, plate-like structure, and that white one is called ferrite. Okay.
Pearlite consists of thin alternating crystals of ferrite and cementite. The white regions are ferrite crystals. They consist of almost pure iron. Great, the etching has been successful. In a similar manner, virtually all materials of our world may be examined. This is the plain carbon steel C80 with 0.8% of carbon. Only pearlitic regions with their characteristic alternating layers of ferrite.
You can see as the percentage of carbon is increasing, you can see the carbon distribution is also increasing. It is only 0.8 per weight percent carbon, but you can see how it is surrounding the structure. And the weight surrounds the structure becomes brittle. It becomes hard, but with hardness comes brittleness also. So that might be for 0.8 weight percent carbon, you can see the microstructure.
Ferrite and cementite can be seen. And this is the plain carbon steel S235 after a color etching. It only has a low carbon content. The relative amount of differently colored ferrite crystals is high, the proportion of pearlite regions low. The variety of materials is huge, and each material needs its own individual preparation method in metallography. The preparation is often not conducted by hand as shown here, but by automatic methods. This saves time and money. The principle, however, is always the same.
Just listen.
Sectioning, mounting, grinding, polishing, and etching.
Okay. Just let me complete types of microscope. Okay. There are 3 types of microscope. I don't know where I have kept my pen. Just let me complete. It's important to complete so that we can upload it properly also. Okay. There are 3 kinds of microscope. I'll just list it for you. Just 1 second. We are just about to end. So sorry, I'll give you lecture attendance for 2 hours and I'll share the link here only. Optical metallurgical microscope. It is having magnification up to 52,000x. One more is there, scanning electron microscope. It is having magnification up to 50,000 times. Okay, and transmission electron microscope, it is having magnification up to 20 lakh times, 2 million times. Okay, I hope you are understanding what I'm saying. This you can see one.
Yes, sir.
Yeah. So sorry, I'm taking your time, but it's important to complete it because I'll not be able to teach you next week. So optical is having 52,000x. What we are having in the college is optical only. No one can afford scanning electronic. It costs in crores. Okay, this is costing in crores. It is only there in IIT and some specific lab which are good for material testing. Okay, we can even plan a visit if this things end. If this coronavirus ends, we can plan a visit also to material testing lab of IIT where we can see microscope and transmission electron microscope. But before seeing this, you should know what do you mean by different kinds of microstructure, what are the properties of material. If you know that thing, that visit will be very useful for students. Okay, next thing, just give me a second, I'm just going to end. Just last slide. So sorry, I'm taking your time. Jana aage papa. 1 second, so sorry. Yeah, next week, scanning electron microscope, transmission electron microscope. Homework, Zakir sir will ask you. Prepare the topic metallurgical microscope by yourself. How does a microscope, metallurgical microscope work? Keep its photo or whatever you want to write in a paper. Keep it in the landscape form in your mobile. Present it by sharing your screen on Zoom. Zakir sir or me will allow you to share the screen on Zoom where in a group of 5, any 5 will be asked to present that topic. Metallurgical microscope will be explained by us. Okay, we will explain this topic to you. And sorry, transmission and scanning will be explained by us, but we expect you to complete metallurgical microscope by yourself as homework for the next week. Okay, anyone who wants to ask the question can ask right now. It's important to ask.
ये चौकीदार
Pucho. Did you understood everything? Anyone can answer.
Yes, sir.
Seriously, everyone. I am asking everyone.
जी सर
Akka.
हाँ
हाँ
Okay. Okay.
ये
चलो
चौकीदार हेलो
बेटा शांत रहो.
नो
सर
डाउट
वो
सर.
सर ये तनवीर से पूछना था 4 बजे लेक्चर होने वाला था ना वो अपने कौन से था वही सर का कुछ तो
भाई सर नहीं लेने वाले लेक्चर, छुट्टी हो जाएगी अभी.